Translating and solving consecutive integer problems. Another type of word problem that you might encounter involves consecutive integers. Consecutive integers are integers that are in a row and have a difference of 1. So examples of these consecutive integers would be 1, 2, 3. They're integers and they have a difference of 1. 3 minus 2 is 1, 2 minus 1 is 1. You can also have negative numbers, right? Integers could also be negative. So consecutive integers for example, could be -6, -5, and -4. And then you could have consecutive integers a little bit higher as 99, 100, and 101. So if we need to solve a consecutive integer word problem, it is necessary to assign a variable to each unknown and then set them equal to the given value. So let's see an example of this. So here we have our example as the sum of two consecutive integers is 57. Find the two integers. So we begin by assigning the first integer as x. Again, it's unknown. We don't know what that first number is. And then the second integer would be x plus 1. Because again, if you have a difference of 1 between the two numbers, if you add 1, you'll get to that next number. It's like going backwards. Instead of a difference of 1, to find the second number, we would add 1. And again, that's for two consecutive integers. Again, using x and x plus 1 would be how you can find those two missing integers. And then we're adding both integer representations and setting the expression equal to the number given. In this case, it's 57. So that equation would be x plus 1 equals 57. We can then solve that equation by combining our like terms. So x plus x is 2x. So 2x plus 1 equals 57. They're then subtracting 1 from both sides to get 2x equals 56. And then we're dividing by 2 on both sides to get x equals 28. So that's our first integer. So once we solve for x, then we can substitute that value in to find the value of the next integer. Because remember, the first integer was x, so the second is x plus 1. So we can do now 28 plus 1, which gives us 29. So the two integers are 28 and 29. And we can always check our work with these problems because the two integers should have a sum of 57. So we can do 28 plus 29 should equal 57. And it does. 57 equals 57 gives us our check. Let's look at two more examples. Let's try to first find the sum of two consecutive integers that has a sum of -33. So here, the first integer we can call x, and the second integer would be x plus 1. Again, we have two consecutive integers, so we can define them as x and x plus 1. Now, they have a sum of -33, so that gives us our equation x plus 1 equals -33. We can then solve that equation by combining like terms. X plus x is 2x. So we have 2x plus 1 equals -33. Subtracting 1 from both sides gives us 2x equals -34. And then dividing both sides by 2 gives us that x equals -17. So that's the first of the two consecutive integers. And then to find the second, we can use the fact that we've defined the second integer as x plus 1. So if x is -17, we would do -17 plus 1, which is where we're getting -16. So the two integers that have a sum of -33, those consecutive integers, is -17 and -16. And if we add -17 plus -16, we do get -33. We get -33 equals -33. Now we have our next example. The second example is the sum of two consecutive integers is 205. So we want to now find those integers. So we have the same setup because again we're talking about two consecutive integers. So we're going to let the first integer be represented by x, and then the second integer would be represented by x plus 1. So now their sum is 205. So that gives us the equation x plus 1 equals 205. And now we can solve that equation for x. We can combine our like terms. X plus x is 2x. 2x plus 1 equals 205. Subtract 1 from both sides gives us 2x equals 204. And then dividing both sides by 2 gives us that x equals 102. So if x equals 102, the next integer would be x 102 plus 1, which gives us 103. So our two consecutive integers that have a sum of 205 is 102 and 103. And we can check because 102 plus 103 should be 205, which it is. It does check out. Now the next two examples are a little harder just because it's not just your traditional setup with two consecutive integers. There are other types of consecutive integer problems. The first is where you can have the sum of three consecutive integers. So it's no longer just going to be x and x plus 1. You have a third integer, which now think if you want to get to the third integer starting at x, now you're not just adding 1, but you're adding 2 to that value. So here in this setup, we have x for the first integer, x plus 1 for the second integer, and x plus 2 for the third integer. Think about just hypothetically, what if it was the sum of 4 consecutive integers? What would represent that fourth integer? So you should think if you're adding another 1 from x, that would be x plus 3. If it was a fifth integer, it would be x plus 4, and so on and so forth. You just keep adding 1 to that first integer of x. Now, we're still talking about the sum, so we have is 93. So that gives us the equation. If we find the sum of those integers, we have x plus 1 plus x plus 2 equals 93. So now we can solve that equation combining like terms of x plus x gives us 3x plus 3 equals 93. Subtracting 3 from both sides gives us that 3x equals 90. And dividing by 3 on both sides gives us that x equals 30. So then x plus 1, 30 plus 1 is 31. And x plus 2, 30 plus 2 is 32. So we have 30, 31, and 32 as our answers. And again, we can check if we add 30 plus 31 plus 32, it should equal 93, which it does. Another way to check is to make sure that when you get your answer, when you solve for x, you're getting an integer. Because, again, you wouldn't want to get a rational number. We can't really have fractions or decimals. They have to be those nice integer values like 30, and even we had negative numbers or 0. So that's a good way to also check your work. Also, as the problems get a little bit harder, it'll be easier to check your work because you're getting more specific with your integers. In this last example, now we have the sum of two consecutive even integers. So now we don't just want numbers that are in a row, we want even numbers that are in a row. So that first integer can still be x, but think about now, let's say for example you have the even integer of 4. If it was a consecutive integer, the next number would be 5, but we want consecutive even integers, so you would then go to 6. Think about if you had 10 and then 12, 20 and then 22. How are you going from x, that first number, to the next number? Well, you're not adding 1, you're adding 2. So the first integer for consecutive even integers would be x, but then the second would be x plus 2. It's different than regular consecutive integers. This is also the same setup for consecutive odd integers because you always will be adding plus 2, plus 4, plus 6. You have to add 2 instead of 1 because you want to skip over that odd integer, or if you're looking for odd integers, you would skip over the even integer. So now if we're told the sum is 114, we have that we can add x plus 2, adding the two integers, and then we have the sum equal to 114. So solving that equation, we have x plus x is 2x. So 2x plus 2 equals 114. We then subtract 2 from both sides, giving us 2x equals 112. And dividing both sides by 2 gives us that x equals 56. This second integer is then if we add 2 to that, we would do 56 plus 2 to give us 58. So 56 plus 58 equals 114, which it does, so it checks out. So those are our two consecutive even integers. So with these problems, it's really important to read what type they want and then actually define your variables. Set up your unknowns so you can keep track of them when you set up your equation and solve.